Next up, we are looking at the first technique used to solve nonlinear inequalities, and we've indicated this technique as being the graphical method. The only time you could use this method is when you know how the final shape of the graph will look like. But let's see how we apply the rules that we've indicated previously. The first rule stated that we cannot multiply by an unknown variable, but luckily this rule applies when we have fractions, and here this is quite a straightforward expression. There's no fractions, so this rule does not apply here. And the second rule stated that we need to factorize. So let's factorize here. X squared minus 2x, right? I'm going to put the 15 on the other side, minus 15 less than 0, right? And then if we factorize, x will have x minus 5, x plus 3 less than equals to 0, right? So the second rule stated that we need to state where the expression is equals to 0. From this we know that we can solve x equals 5, and we can solve also x equals minus 3, right? So we're looking at the graphical method. The graphical method, you assume that you know how this graph will look like. So if we would quickly draw this graph, right? So the graphical method is strictly using how the graph looks like to quickly solve the problem. We could have literally stopped here when using the graphical method if you know how this graph will look like. Here we have the roots. We have minus 3. On the other side we have 5. These are the two x's. And then here we have minus 15, right? But the question asks us, where will this graph, notice how we use the inequality expression, where will this graph, right? If we assume this is the y graph, right? Where will this graph be less than 0, right? In other words, here's the graph, right? Where will this graph be negative? Because anything less than 0 is negative, right? Do you notice here the graph is positive, right? But here, because when I mean the graph, I don't mean the x value, I mean the y value, because here on the x-axis we have the x-axis, we have the y-axis. So we can see here y is positive on this region. Here's y is positive in this region. And then if we come back to this region, you see here y is negative, right? So the entire region here, y is negative, right? And then on this entire region, it's positive again. So the question asks us, where will this graph y be negative? Where y is negative. So do you notice the question is asking, for which values of x will y be negative? Do you notice that between x equals minus 3 and x equals 5, which is this region, y is less than and equal to 0. In other words, it's negative or equal to 0. So the answer to this thing, solve for values of x such that this graph is negative or this graph is equal to 0. So we've solved the points where the graph is equal to 0. It's that point and that point. And the points where this graph is negative, it's between minus 3 and 5. So the answer to this is x must be between or equals to, right? So x must be between minus 3 and 5. So that's the answer to this problem. And I want to bring your attention to the second rule. Why should we solve the points where the graph equals 0. It's going to prove pretty much useful when we're using the table method. Notice that here are the roots, right? And we said that the reason being we're solving for roots is that the graph changes signs there. Notice that here it's positive, and then we arrive at the root and it's negative here, and then we arrive at another root, it becomes positive. So it's quite important that we solve for these because they tell us about how the graph changes. That's not pretty much useful in this graphical method, but it's going to be very useful when we're using the table method, which will be demonstrated in the next video.